Hi, I'm Chris with Sanderson Test Prep, and we are going to take a look at two grid-in questions from College Board SAT Practice Test 5. So these are questions 37 and 38 in section 4, which is the calculator section of the math. And in theory, if you're at the tail end of that grid-in section, it means that you should be getting to the hardest problems in the section. And these are questions that do oftentimes throw students for a little bit of a loop, so I want to make sure that we can take a look at how to approach these effectively. So first, let's take a look at the overview. It says questions 37 and 38 refer to the following information, and they give us this table along with a description. Let's talk through what information we see here. So we have different segments of a commute. It's a workday morning drive, and we have from home to freeway, freeway to exit, exit to workplace, and the distances for each along with the average driving speed for each. So hopefully when we see some distances and then when we see speed or rate, that we're going to start thinking of a certain equation. The equation we want to come to mind is going to be distance equals rate times time. So let's write that down over here, and that should be something that, again, we recognize when we first see that those are the units that we're dealing with. If they start giving you distances and rates, or distances and times, or rates and times, anytime they offer two out of these three pieces, we want that equation to come to mind readily. So next it says, Miss Simon drives her car from her home to her workplace every workday morning. The table above shows the distance in miles and her average driving speed in miles per hour when there is no traffic delay for each segment of her drive. So keep in mind the one stipulation that they offer here is that this is specific to when there's no traffic delay. And if we're doing good anticipatory test taking, then we're thinking to ourselves that there might be a scenario. If these are the pieces of data for no traffic delay, they might ask us a question where they add in some type of traffic delay. So that's something we might anticipate and just be on the lookout for when we get to the actual question. All right, let's tackle 37. One morning, Miss Simon drove directly from her home to her workplace in 24 minutes. What was her average speed in miles per hour during her drive? So for average speed, we are looking at, if we base it off this distance equals rate times time equation, if you rearrange to solve for rate, R would be equal to your distance over your time. And if we're talking about an average speed, that means that we're looking at those totals, which is really important. So it's total distance over total time. And here we are going to use this first column of our table to find that value for total distance. So we're going to add these up. 0.6 plus 15.4 is 16, plus 1.4 would be 17.4 miles. And the units that they're asking for are miles per hour. So we're going to have 17.4 over. Now notice it's miles per hour, and the time they give us is in minutes. So we have to do a conversion here. It's going to be 24 divided by 60 to put that into hours. And so when we do that, 24 divided by 60 comes out to be 0.4. And then when we calculate 17.4 divided by 0.4, we get for our total. And if you want, you can do this in two ways. So it is calculator section, so we can use calculator. But let's say we had this in a non-calculator section. Is there an easier way to evaluate this same calculation? And we can evaluate this by moving the decimal over one space for each. And again, if it's calculator based, you could just type it in. But we could also calculate this as 174 divided by 4, which might make the math easier if you had to approach this in a non-calculator section. When we do the calculation here, we get a total of 43.5 as our grand total for question 37 in miles per hour. Now let's take a look at question 38. If Miss Simon starts her drive at 6:30 a.m., she can drive at her average driving speed with no traffic delay. If she starts her drive at 7 a.m., the travel time from the freeway entrance to the freeway exit increases by 33%. So this is kind of what we talked about when we saw that the initial data was for no traffic delay. We thought maybe that is going to invite a question where they add in a traffic delay, and that's exactly what we see here. So it says the travel time for each of the other segments does not change. Based on this table, how many more minutes does Miss Simon take to arrive at her workplace if she starts her drive at 7 rather than at 6:30? Okay, so if she starts at 7 instead of 6:30, it's affecting part of the trip. It says it's affecting this part. So we're going to highlight the information in question, which is this is the part that's changing. So these are going to cancel out because they're not going to impact the driving time. Those driving times will be the same. So the only added driving time that we'll experience here will be whatever added time we have from freeway entrance to freeway exit as we increase this driving time. So let's take a look at how we can use that information to do a calculation here. It says from freeway entrance to freeway exit, it'll increase by 33%. Well, let's take a look at the current time. We have a distance and a rate, but we don't have a time, so we're going to have to calculate a time. So in this case, if we do a distance equals rate times time calculation, and we go to solve for t, our time would equal our distance divided by our rate, which would be a distance of 15.4 miles. And if we divide by 50, so that's going to give us a time. And let's talk about what units that time would be in. So that would be 0.308. But the units here are hours. And this question is asking us in minutes. And they even underline it for us, which is very nice. A lot of times they'll sneak it in there in a word problem. So just make sure for any word problems, especially when you're dealing with distance, rate, and time, it's very common that they'll switch back and forth between miles per hour or total minutes or total hours. And you want to make sure that you're being really careful about units. So we want to know if the current time is 0.308 hours, if we multiply that by 60, that will allow us to see what that current time is in minutes. And so currently, that would be 18.48 minutes. Now in the question, they want to know, all right, what if that travel time increases by 33%? Let's see how many more minutes that adds on. So to calculate a 33% increase, for percent change, when you have an increase, you can treat it as 1 plus that decimal value, or 100% is your original travel time. And then with the increase in 33%, it's now going to be 133% of your original, which means you're multiplying by 1.33. If you have questions on that, please check out one of our other videos about percent change, because that's a really important shortcut to percent change to allow you to calculate that new value. And so here the new value of minutes would be 18.48 times 1.33. And let's see what we get when we do that calculation. And that comes out to 24.578, or 58 if we round it. And they want the value rounded to the nearest minute. So this is going to come out to 6.1 when you take the difference, and 24.58 minus 18.48 is 6.1, which for our answer means that we're bubbling in 6. Because they say round your answer to the nearest minute. And again, for grid-ins, we have to be very careful about some of those kinds of things to make sure that we end up getting the credit for the question that we spend so much time solving. So questions 37 and 38 here with this information are pretty challenging questions. And some of the takeaway messages are: 1, make sure that we know distance equals rate times time. This is a really important equation for us to know. 2, make sure that we know when you're talking about an average, you're talking about your total distance over total time. And then 3, as we see in both questions, sometimes we're going to have to do conversions. Make sure that you're careful about your units. Miles per hour, minutes, total hours, etc. So those are 3 keys to take away from this example of a distance, rate, and time relationship for these 2 tough SAT questions, again from College Board Practice Test number 5. For more, please check out our other videos, and thanks for watching.